You guys will bear with me, but I can assure you that you are going to get the. I'll try my best to make sure you properly understand how to write smart contracts. You understand at least this will be a foundation for you in the Web3 space. This we're just covering Solidity. If you want to explore Solana blockchain, you you can like you can delve into Rust, or you want to explore um, Tom blockchain, you write Funk. Funk is the language that is used there. But let me not go into much details. So um, from what we have if you check what we have in the curriculum I sent, what we'll be going through today, um, with for module one, we're under module one, and it's just introduction to blockchain and Ethereum. You get so I divided into since the boot camp is for 8 weeks, so I made sure that I spanned it across. We have 5 modules, and I spanned it across the 8 weeks. You get, and then our course is Wednesdays and Fridays, 2 p.m. to 4 p.m. Except I can't meet up with that time, we will schedule for 10 p.m. to 12 a.m. So I don't know. Can you guys hear me? Let me make sure. Yeah.
Yeah, I can hear you properly.
Okay. 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 So well, okay. Let me first go through what will be under like module one, introduction to blockchain. For today, we'll be covering blockchain basics, decentralization and distributed ledger technology, consensus mechanisms. Like that's where we have POW, proof of work and proof of stake, and then cryptography and security. So but before we move on, I would like to know you guys since like thank God we are not much. I think we're like just we're nine. So just about three of you that are here also. So I would like to meet you guys. You can introduce yourself and like details about yourself. Are you a student of Unilag? What's your course of study? How long have you been into tech? Is Solidity your first language, or you are already into a particular part of tech? You now want to delve into writing smart contracts? Just let me know.
Okay, I'll start first. My name is Uchiroya. I'm a Unilag student, physics 300 level. Uh, I'm a web developer. But I started Solidity this year. I know the fundamental of Solidity, like writing functions, construct, modifier, do stuff. I know, but I'm not a professional, so that's why I applied for this program. Okay, thank you. That's all.
Okay, okay. Welcome, Uchi Royal. And I hope I'm glad that you're already into tech. You say you even know like at least um you're comfortable. I'll say you're comfortable with Solidity, but you still want to like go deeper. You get into Solidity. Yeah, that's nice. I think I did not even do a breakdown of myself there. So I myself, let me introduce myself. Yeah, I did not introduce myself. So I am Divine Favor Chinedu. That's my name, and I am also a Unilag student. I'm a 200 level. I'm going to 300 now. We just finished the semester. But let me see. I ingoing is it ingoing? I'll say now ingoing 300 level student of statistics department. Yeah, and I've been in the tech space for about 5 years now. And basically, the kind of person I am a polymath. Like I'm not keen on one career path in my in my years in this tech space, I have delved into data science, though I didn't work professionally as a data scientist, but I started my tech career with Python, data science, and then I delved to because of I needed money. I delved into web development. I started doing backend with Node.js, and then I did backend, and then I worked for a Nigerian company for a year and a half. As a backend developer, I was writing Node.js, Nest.js as the framework that with TypeScript. So, and then I now I wrote backend with Django and Fast API too. So because I write Python, Python was my first language. So and then um, I delved into technical writing. So that's when I got a role as in a blockchain company. I don't know if you know Cello blockchain. I don't know if any of you know Cello blockchain, but I worked at Cello as a technical writer. I was writing developer documentation for their developer community, writing tutorials on Solidity, on building on Cello, deploying your smart contract on Cello, things like that, integrating Cello, and then using tools like languages like Python or Golang for your deployment. So that's what I did. And that was just last year. I got into this Web3 space early last year. That was like February last year. So, and then I got a role. I was working there. Then I also, that same last year, I got into quantitative finance. So I think I'll drop my LinkedIn after this call on the group so we can connect on LinkedIn. So I got into quantitative finance. I don't know how you guys like if you guys know what quantitative finance is, but basically, in summary, quantitative finance just involves so yeah, like we'll be taking this much time introducing ourselves. We're not going to be writing code today. Yeah, it's just we're just going to go through the basics of blockchain technology and also we can use 1 hour for that or less, depends. So quantitative finance just involves using as the name implies, using quantitative or algorithmic um, models to find alphas in the financial markets. So if you've heard of hedge funds, Wall Street, so in simple term, I'm just using statistical or mathematical or AI algorithms to find patterns in financial data for different asset classes. Like now in commodities, we have gold, we have silver, we have crude oil for stocks in the stock market, for currency market, the forex market, for crypto market, and then also in DeFi too, decentralized finance. So basically using data to find like strategies or ways in which you can increase asset returns, like your your portfolio size. Let's say when you invest $1,000, like what will be your returns after so time? Like you simulate it using metrics, statistical metrics. So I'm applying what I'm studying to work again. So though I didn't work in an hedge fund or an asset management firm, but I worked on a contract for a client last year, and I built a trading algorithm to get on the crypto market. You get that trades the crypto market. So that's quant. Basically, that's what quant finance is. Yeah, a lot of people don't really know about it. But right now, I'm more of like merging finance and tech. You get because that's where the money is. That is where the money is. Because I know that's why most of us are trying to learn solidity because it's a at least the Web3 space is only in the Web3 space that you'll be seeing ridiculous amounts. Um, I have some of my guys that were 3 designers. For a landing page, they can charge a client like $5,000, sometimes $10,000 for just landing page. You get so um, Web 3 is not like Web 2. in this space, like there's a lot of money like flowing in, and then less competition compared to Web 2. You get, and one tip I can give you is that in this space, try to don't follow don't follow the crowd like too much. You get, let's say look at targeted blockchains. Let's say for example, say network, say SE SEI, say is a protocol, the blockchain protocol. I think their language is called Move. So you don't have to like just like if you learn Solidity, stay on Solidity. If you want to chase opportunities, contribute to like open source to this. You can look at you can look at Stacknet. Those protocols are a lot of you know that Ethereum is already like people that are in this space. You know, Ethereum is already like is the most used blockchain. A lot of people are writing Solidity in this Web3 space, so the competition might be more. So you can go into the ones that are less competitive, and there's money there. You get, or you can start up your own products like me. Start up your own product. There are a lot of things you can think of on like, okay, how do we use blockchain technology to solve this? How do we use it to solve that? Like that, like that. But uh, I think that's it. So the rest of you, let me just hear. Um, I think it's just the two, three of you left. Two. Let me just hear. Tell me about yourself. I know. Maybe I should call him. Okay, Udoka Obi. Can you tell us? Udoka Obi, are you there? Oh, I don't think he's there. What of Timmy? Sorry, am I what will I say? Can you guys hear me?
Yeah, I can hear you.
I was unmuted. I was muted. Okay, so I started my tech journey
Okay.
last year. Well, so far I've been focused on database administration and database and data engineering. But I'm looking to pivot into Web3 because I've learned of the opportunities that are involved in it. And that's everything I have to say.
Okay, interesting, interesting. So, and one thing you should know is that you don't have to really, okay, you said you're heading into data engineering. So the thing is, you can do data science or data engineering in the Web3 space. I don't know if you get me. You can do that in the Web3 space. You can learn how to work with Web3 data. You get to solve. Okay, like
Like,
one of the
mm,
yeah,
okay. I've been learning
yeah. What did
about
you say?
Dune, but I'm still looking into it.
Okay. Dune is an analytics platform for Web3 data. You get, so right, even right now, one of the products I am working on with my team is we are building a real-time um, both for devs and users, where you can track on-chain activity, a platform where you can track like wallet transactions on chain. And then for devs, you can download historical data. For data scientists, you can work with historical data. You need to make use it for probably your business to make investment decisions in the DeFi space. We're applying AI, machine learning algorithms to DeFi, decentralized finance. You know, decentralized finance is just one of the application of blockchain, and is the most used application of blockchain right now. That's where there's more liquidity, a lot of inflow of cash and money is in the DeFi space, decentralized finance space. So yeah, teammates, nice hearing of that. I don't know. I didn't even hear like what department are you in and what?
I'm in mechanical engineering. Although no, I finished mechanical engineering this year. So I just graduated.
Oh,
So
oh, okay. Wow, that means you would know John Kudus.
yeah, those are big bosses. They are into Flutter in it.
Yeah, yeah,
Flutter.
they're my guys. They're my guys. Okay, nice, nice. So, who else is on this call? Okay, Udoka. It's just you. I don't know if you can hear us.
Yes, I can hear you. Can you hear me?
Okay, yeah, I can hear you.
All right. Good evening. My name is Udoka. I actually finished with in human kinetics last year, December to be precise. So I got into the tech space. That was 3 years ago. That was in 2022, precisely. So I, like you said, I actually dabbled into different fields in data science, in front end and then back end. Then as for Solidity, I actually started that same year, but I was not fully concentrated because I was still in school. Those are my projects and all. So this year I tried picking it up with personal trainings and all that. But when I saw the advertisement on Instagram, I just had to take it. And so that's why I'm here. Thank you.
Okay, okay. All right. That's nice. It's nice meeting you, Udoka. So, okay, that means you're already in the, at least you're already living after school life already. You're living after school life. So it's good. It's good. It's good for us to acquire these skill sets and then um source for opportunities yourself. I'll tell you this. Um, the tech space right now is like, let's say, it's more like survival of the fittest. So you need to be good at what you do. You need to be good at what you do. You need to network. So make sure you guys like attend, as you are into web, coming to Web3 space now. Attend Web3 events. Build, build, build in the public. Let people see like what you do. Let people know what you do. Speak about what you do on Twitter. Post it. Post on Twitter. Let people know what you do. Put it in your profile that this is what you do. And then also be reaching out to these protocols. When I mean protocols, like you can contribute to their GitHub, and then you can, in fact, you can even do technical writing for Web3. You can do technical writing in the Web3 space. So um, reach out to this protocol. Look for how you can contribute to their documentation and all. So that's, I think that's all on introduction. Let's move on to the course contents or the curriculum content. Um, so like I said, today we'll be talking about blockchain basics, decentralization and distributed ledger technology, consensus mechanisms, cryptography, and security. So, um, I don't know, you guys that, okay, I think who even said that they're already writing? Who said is already in the space that is at surface level? I think it was Royal. Yeah, I think it was Uche Royal. I think you're the one. So, like, can you just like tell me when you hear, since we're starting from the very basics now, something that you would, let me just like know like how grounded you are. So, when you hear blockchain, like, what comes to your mind? Can I just, because I want to make the learning interactive. You get. Thank God we are smaller. Assuming we were like the some assuming we were like 20 or more, it would not be possible for us to like communicate this way. But let me just know, when you hear of blockchain technology, what comes to your mind? Or blockchain?
Okay. Okay, blockchain technology is a distribution of an immutable ledger along different systems, which they are called nodes. Hope you understand me.
Okay, okay, yeah, 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 yes,
Yeah,
yeah, yeah, yeah. So, but then let me just try to basically, when you hear blockchain, blockchain is just a distributed, decentralized, public digital ledger consisting of records. These records are called blocks. They're called blocks. So these blocks then record transactions you get across different nodes. So it's more like how will I put it now? It's just like what example can I give now? So just like in the company when they are keeping financial records, you get they're keeping financial records. The account statement itself is the blockchain. You get. Then there are different financial records. Yeah. And these records should be publicly available. Sometimes some companies don't make their records public. So, but these records should just be publicly available, you get. And then um every of the records are like different blocks, you get. There are different blocks, and these blocks contains these different records or blocks now contains different transactions, let's say inflow and outflow of money in that particular organization, you get. I don't know if you understand like that explanation. Do you guys like understand that explanation?
yeah, yeah.
Okay, okay, so
Yes,
it's
thank
just
you.
like okay, so it's just like the blockchain is just like a public database. You get. Now, in the normal Web2 space, when you build backend, like for as many of you that are probably you've done backend before. So if you do backend, you have to have a database, you have to build your API. Your API is API is application programming interface. So it's just more like uh, the intermediary between your clients and your database. So your clients can be your front end, or if you are building a bot, it can be the bot, the interface. So, and then you have your database. So, I know your database can be structured or non-structured. That's where you talk about MongoDB or SQL and all. So, um, now when you build in Web2, these databases that you use, they are private. It's only you that can have access to it. That's why you have like passwords for this database. But now the blockchain is like publicly available. Anytime a transaction is done on the blockchain, I can view that transaction on that particular blockchain. I can go and check like the block time, details like the block time, the transaction amount, the so many like the address of that particular of wallet. So it's publicly available to the public. Like every single detail is available, except when you talk about there are privacy, like there are privacy technologies in the blockchain space, things like zero knowledge, but that one is more advanced. Even I myself, I don't know. I just know about zero knowledge technology, but I've not built something on zero knowledge because it has to do like it's very deep. It has deep cryptographic structures, and it involves a whole lot of mathematical algorithms. Zero knowledge proof. So, but that aside, the blockchain is just a public. ledger where people can verify transactions. You get through like different blocks. So, what are the key characteristics of blockchain technology? Why is the blockchain, why is it different from normal traditional databases, or um, why is it the blockchain? What makes it unique? Number one, the blockchain itself is immutable. So when you say something is immutable, so once data have been stored on the blockchain, you cannot modify it. You get, it's not like how will I put it now? When you're the same thing, if you're a backend developer, it will be very easy for you to understand this, because if you are building backends, you know that there are CRUD operations. That's the basic listing of backend CRUD. That's create, read, update, and delete. So when you are writing your API, then if you are doing a create operation, you know that you are creating something and then you are storing it on the database. If you are reading, that's more like get request. If you are U stand for updating, so you can update something on the database, probably by the ID or something, and then you can delete. So it's more like on the blockchain, it's only that CR, that CRUD, that CR, that's what is there. The UD is not there. You can't update and you can't delete. You can't delete something that is already on the blockchain. It's there, is already there. You get. But now, um, yeah, the blockchain is immutable. Though there are some things they are bringing to the blockchain now that you can update some things. You get, boys is like on playing ground. It's difficult to um change what you've stored on the blockchain. So that's immutability. Then we have immutability, sorry. And then we have transparency. So anybody can view the content or transactions. Everything stored on the blockchain are in form of transactions. You get, so from when you deploy a token, when you mint an NFT, everything is going to be stored as transactions on the blockchain. So the blockchain transactions are transparent. Anybody can view those transactions. Anybody around the world can just go and view it. Unlike your normal bank statements, where only you can view your bank statements, except probably you allow people see it. You get, but only you can view it. But on the blockchain, anybody can see your transactions, so it's transparent. Then it's another characteristic is decentralization. Because that means there is no single body regulation, like body controlling the blockchain. So that's why anybody can just come and then carry out a transaction on the blockchain. Everything is carried out by smart contracts, what they call smart contracts. So there's no like I'm into quantitative finance. In the stock market, we have the like in the US, we have the New York Stock Exchange. We have these New York Stock Exchange are like regulating bodies for stocks. You get, for stocks. Even in Nigeria, yeah, for financial system, we have NIBS. You know of NIBS. NIBS is the regulation body for fintechs. For fintechs, that's where all fintechs get their data from. So that is a regulation, like it's more like a body that regulates everything. But on the blockchain is decentralized. Everything is on chain. You get, so those are the characteristics of the blockchain. I don't know, did I explain it well? Or is there anything that you guys don't get?
I understand you right.
Okay, okay, okay. So
Yeah.
okay. So moving on, um, this blockchain technology, like when did it start? You get, they call this man the father of Bitcoin. That's Nakamoto Satoshi, or whatever his name is, Satoshi, how they call him. He released the first Bitcoin white paper. Bitcoin is the first token that was launched on the blockchain. Bitcoin is the first blockchain and the first token, BTC, that was launched. Um, um, that was launched in 2008, and then in 2009, the first Bitcoin block was mined. It was mined because all these blocks, yeah, I don't want to go into consensus mechanism yet. We've not gotten there, but um, all these blocks, yeah, they are being verified before a block is created. When a transaction is carried out, a validator um, approves that transaction, yet, and then it's being stored in a block. So, but in 2009, the first block was mined, Bitcoin block was mined. Then 2015, that's when Ethereum launched. And then Ethereum and the EVM, Ethereum virtual machine, is the most used blockchain in the world right now. Most Ethereum is a layer 1 blockchain. It's what they call layer 1 and layer 2. There's even layer 0 now. Sure. The layer 0, there's layer 3. But layer 1 blockchains are Ethereum and Bitcoin. Okay, those are layer 1 blockchains. So they are the blockchains that other blockchains were built on top of. You get so, and these layer 1 blockchains have their limitations, things like speed. They don't have speed. They process transaction like like Ethereum. I think Ethereum processes like maybe 20 transactions in maybe 2 minutes or thereabouts. I can't really confirm. I can't really remember, but it's slow. Unlike Solana, Solana is a layer 2 blockchain. It's very fast. It processes transaction in like millisecond, like 400 milliseconds. So it's faster. That's why Ethereum transactions, um, like before a transaction is being confirmed on a block or by a validator on Ethereum, there's always like these pending transactions are being like there's what they call mempool. The mempool, that's like an advanced concept, but the mempool is where these transactions, like pending transactions, are. So that's how people can manipulate in on the Ethereum blockchain. There's what they call MEVs. So it's very good that you guys understand this concept. What they call MEVs, minimal extractable values. So there are some people that can build bots, some developers, they can build bots that can front run your transactions on Ethereum. If you don't know about it, if your wallet is not protected, they can front run your transactions, and then they would front running your transaction does not mean they will hack you, but they will check for pending. Let's see, let me use a scenario now. If someone wants to front run my transaction, let's say I want to buy, let's say I have $100 worth of ETH, Ethereum, ETH on my wallet, and then I want to buy $100 worth of ETH of a token. I want to buy a token for $100 worth of ETH. So now, if I place that transaction to buy that token, now that transaction is going to be processed on the main pool, and then if someone front run my transaction, the person can pay a higher, because the way validators mine a particular block where your transaction is, before they can a validator approve your transaction, is based on the gas fee you pay. So sometimes in Ethereum, they can pay you like the the person that is controlling your transaction will just have to pay a higher gas fee, and then his transaction will be placed first before your own. You get, then it will be validated by a validator. Probably this information is very, I don't know if you guys are getting me, but it's going to be validated by a validator, and then their transaction is going to go first before your own. So they are going to probably buy a large volume of that token, and then it's going to cause a very large price impact. So now probably you're supposed to buy $100 worth of that token now, and then get a particular amount. You might now use just $95 instead of $100 to buy the same quantity that you want. So you are going to be buying at a higher price because they front run your transaction. So like that's just the summary, sha. So that's those are the limitations of Ethereum, sha, because it's a layer one blockchain. It processes transactions slower, you get, but it's still the most used um blockchain to date, Ethereum. And most layer two blockchains are built on top of Ethereum. So um now let's go to decentralization and distributed ledger technology. So when they say centralized and decentralized systems, what do we mean? So what does centralized system mean? When you hear centralized system, basically just like it involves a single point of control and failure. So just like banks, in banks today, like I said, institutional banks can fail tomorrow. Something can happen and then NIBS is going to be down and then everybody will be stranded in the whole country. I think there was one time NIBS was down and then everybody was stranded. So there's just one single point of control in centralized system, though it's faster and easier to manage. You get. So, like I said, examples of centralized system are traditional banks, social media platforms like where you have Facebook, Twitter. Those are centralized system. Then decentralized system, there's no point of control in decentralized systems. It's is more resilient to failures and attack. That's if these smart contracts are implemented well, because there has to be smart contract attacks. Like there are protocols that have been attacked where hackers steal like millions and millions of dollars from these top DeFi protocols. So, but that aside, example of decentralized systems, we have Bitcoin and Ethereum. Now let's move on to decentralized ledger technology. So when they say decentralized ledger technology, what does it mean? So decentralized ledger technology is just a digital system for recording the transaction of assets. The transactions and the details of these transactions are recorded in multiple places at the same time. So that's why it's because these different the blockchain here is just like the blockchain is a connection of nodes. You get, these decentralized systems are just different nodes that are connected together. Now, a snapshot of a transaction you make is going to be stored in different parts, different nodes. So whenever you make a transaction, whenever you make a transaction, sorry, on the blockchain, a snapshot of it is being stored on these different nodes that are connected. You get, so that's why it's called a decentralized system, a decentralized ledger. As far as these nodes are connected, as far as one of the node is still running, your transaction will still go through. At least, as far as at least one of the node is still running. So let's say out of all the nodes running, for let's say Ethereum blockchain, if all the nodes are down and one is still running, transactions will still go through. Just that it will be slower, you get, because one node is still available to carry out that transaction. So, how does distributed ledger technology works? You get how it works. Your transaction is requested, then transaction is broadcasted to a P2P network, that's peer-to-peer network. You get, the network of nodes validates the transactions. Now, once they validate that transaction, the transaction is combined with other transactions to create a new block. So within a particular block, there are different transactions under that block. You get, so and then the new block is then added to the existing blockchain. So the blockchain is just that's where the name comes from, blockchain. So it's just like a chain of blocks, different blocks. Blockchain is just a chain of different blocks, and these blocks are just different nodes. These nodes validate transaction, you get, and these nodes, like now, as you are now, you can run a blockchain node. anybody can run a blockchain node. Just that to run a blockchain node is expensive, okay, but you can run your own because it has like there's a lot of like computational resources and all. And when you run a blockchain node, you're going to be paid for it. On Ethereum now, if you run an Ethereum node, out of the gas fees, what they call gas fees, out of the gas fees that Ethereum charges for transactions, they pay part of the gas fees to validators. They call them validators because you are running nodes and verifying transactions. So it's more like you are contributing, just like the way you contribute to open source. So you are contributing to the ecosystem by running your own node, and then you are becoming a validator. So I don't know. I think I've said too much. Like, do you guys get all what I've been saying?
Yeah, yeah.
Yeah, brilliant.
Okay, okay. So I just want to make sure that because before you start writing Solidity, these are things that, okay, let's say you want to go for interview. If you're going for interview, at least they have to make sure that you have a solid understanding of the blockchain. You get, even though they are going to ask you stuff about Solidity, you get, but you have to be grounded in knowledge, like knowledge about the blockchain. How does it transact? Yeah. So moving on. Sorry, the call is coming. Sorry. Moving on. Benefit of distributed ledger technology, we have transparency is increased, enhanced security is more secure. You can improve traceability, so you can trace anything on the blockchain. You can investigate on the blockchain. That's also one of the products I'm working on, the data platform for blockchain. That's one of the feature we're working on. So you can trace anything on the blockchain. The blockchain is faster, like is efficient and it's fast, and then it reduces costs too. Now, moving on to, will I say, the most important part now, consensus mechanism. So when you hear of consensus mechanism in the blockchain, consensus mechanism are just protocols that ensures that all nodes in a blockchain network agree on the state of the blockchain. So it's just like a term that is a term that how will I put it now? It's just a mechanism, basically. Consensus is a mechanism that ensures that all the nodes in a particular blockchain are in a current are all in they agree together to be on a current state. Now, there are different consensus mechanisms of the blockchain. We have proof of work, we have proof of stake. Though there are like other like these things are coming out these days. There's proof of ownership, there's proof of which one again, Seth? There are different like
Transaction.
yeah, proof of transaction. So there are different proofs now these days. There's what they call reward assets. You get, I think I'm working on something around that space too. Reward assets, where we have like it's more like you're tokenizing reward assets like real estate, collectibles, commodities. So that one now, we have like proof of let's say you want to verify a bank statement, proof of bank statement or something. There are just different proofs, sha, but the most common ones now, consensus mechanism, is proof of stake and proof of work. So Ethereum was using proof of work before, but now Ethereum is using proof of stake. I think that was Ethereum moved from proof of work to proof of stake in it was not long ago. I think it was last year. That's what they call the merge. If you check the merge, you can check it online, the merge. So that's when Ethereum 2.0 came out, the merge. So that's when Ethereum moved from proof of work to proof of stake. So proof of work is more energy consuming. Like that was what's like, sorry, there's noise. Can you guys hear me?
Yeah, I can hear you.
Okay. So proof of work was used by like is used by Bitcoin, and then Ethereum also used it before moving to proof of stake. So the way proof of work works is that, as the name implies, proof of work. You have to, it's more like you'll be paid according to the work you put in. So miners, these miners of these different blocks compete to solve complex mathematical puzzles. You get defined by like some cryptographic shit. Like those are, we are just writing smart contracts. They are like core blockchain developers that do all this cryptography. That's like hard part of blockchain. All this zero knowledge, they do cryptography and all, but we were writing smart contracts, building dApps. We are just like, will I say, we are the ones enjoying. Yeah, just like in normal Web3 space, where we have people that do distributed systems, like people that work in AWS now that build these instances, these different like um, nodes and all distributed systems. Those are like hard part of software engineering. So, but we just do like web and all. So the same thing here. Like as I was saying concerning proof of work, miners compete to solve complex mathematical like puzzles, and then the first to solve it gets the next block and receive a reward. So the first to solve the puzzle, the mathematical puzzle, just receives a reward, which is like in Ethereum, ETH, that ETH, that's the token for Ethereum. You get proof of work. So they receive ETH as reward. And then what are the pros? The pros of proof of work is that it is secure. It has proven to be secure over time since 2005 when, sorry, not 2005. Ethereum came out in 2015. Since 2015 till like 2022 when they stopped. I've forgotten the year they stopped. The Ethereum merge, I've forgotten again. But it was recent, sha. That's when they stopped using it. And then it's decentralized. Then what are the cons? Um, it's energy intensive, like that the power of mechanism, like it consumes a whole lot of energy, a whole lot. So now moving on to proof of stake. Now, how does proof of stake works? So validators are their now for proof of work, they compete. These different validators, these different people, they compete. You get to run the next block, and then when they solve it, they are being rewarded for it. Now, for proof of stake, validators are choosing to create a new block based on their stake. So it's based, that means you are going to stake Ethereum. In this case, now for Ethereum, you are going to stake Ethereum, and you get create a new set. And then validators put up a stake as collateral, which can be slashed if they behave maliciously. So if they do anyhow, they are going to be penalized for it. If these deep validators that in proof of stake mechanisms now, if they alter the state of the blockchain, you get, they are going to be penalized for it. So their stake, this the money they stake, or the Ethereum in this case that they staked, is going to be a particular portion is going to remove from it. So that's just how proof of stake works. And then the pros is that it's more energy efficient. Um, it is potentially more decentralized. You get, and then the cons is that um, uh, there's this rich get richer concerns. So for proof of stake now is according to your stake. That's the more money you're going to be making according to your stake. Then you'll be given new blocks to mine according to your stake in the blockchain. So it's more like the person that has the most stake is the one that is going to run more blocks, and then the person that is going to receive more rewards. So um Yeah, that's the cons, sure. And then we have, let me just say, basic cryptographic concepts. When you hear cryptography, I don't know if you do backend, yeah, there's this there are hashing algorithms, and those algorithms are cryptographic in nature. Things like hash 25Cs, uh, which other cryptographic algorithm? There are different cryptographic algorithms, sha, and that's where you do when you are doing auth in backend. I don't know if you guys, any of you did backend, sha. When you are doing authentication, this JWT and all, JWT tokens and all. So there's like a little bit of cryptography. The way you store passwords on the backend, you have to hash it and all. That's cryptography there. So um, in the blockchain, in this case, cryptography now, what's public key cryptography? What does it mean? Public key cryptography, we have the public key and then we have the private key. If you if you've used wallets before, blockchain wallets before, you hear when you create, let's say MetaMask, when you create a wallet, they'll tell you save your private key. If you lose your private key, or if anybody have access to your private key, they can withdraw all your funds in your wallet. So your public key is just your public address. Get your the address for that particular wallet, the public address. That's one you can share, so people can see it. It's used to encrypt messages or verify signature. So you can verify a transaction with your public key. Then your private key, use it to create signature and then use it to decrypt messages. It should be kept as a secret because once someone have access to your private key, they've hacked your wallet. So then we have hash functions. So hash functions, we have it involves like is a one-way function that converts input data into a fixed size output. So no matter the input you put, is going to come out as a fixed output. You don't really know, you need to like, because you're not going to be doing cryptography. That's like, say, if you want to do core blockchain stuff or no. Even I myself, I don't really know cryptography. I just know the basics of cryptography. Then, what are the properties of hash functions? They are deterministic, they are quick to compute, and then infeasibility to reverse. That means once you use a hash function to hash something, you cannot reverse it. Once you use it to hash a particular algorithm, you can't reverse it. Then let's move on to blockchain security. So each block contains the hash of the previous block, creating a chain. I think there's this particular website where you can like simulate how these blocks work. I've forgotten the name of the website, but you can just like just have this basic knowledge. Each block contains the hash of the previous block. You get creating a chain. That's what creates a chain. So from the first block, when the first block is mined, moving on to the next block, the hash of the previous block is going to like be on the next block, and then it's going to be creating a chain. That's what forms all these like different chains that are connected to different blocks. That's why they call it blockchain. And each block contains transactions and then transaction hash. Then changing a block would require changing all subsequent blocks. Distributed nature means multiple copies of the ledger exist. Like I said, um, different snapshots of these transactions are on different blocks on the blockchain. So uh, as far as one block or one node is running, as far as one node is running, the decentralized nature of the blockchain is still going to stand. So I think that's where I'll just end for today. I think that's where I'll end for today. So I don't know. Our next class is on Friday. It's on Friday. That's where I'll talk about Ethereum. I'll be talking about blockchain. Talk about Ethereum. Though I think I've talked a little bit about Ethereum too. Talk a little bit about some advanced concepts that are even out of the scope of this course, of this curriculum. Then we're going to talk about Ethereum, the Ethereum virtual machine (EVM), smart contract and the application, the Ethereum ecosystem, and then from next week, that's when we'll start writing Solidity. So I don't know. Okay, I think Roya, you raised your hand.
Yeah, yeah. I want to ask a question regarding the proof of work and proof of stake. I know that for proof
Okay,
of work, you actually have to have a node, like a machine to run computations for you in order to process the block. But for
yeah.
proof of stake, where actually do you stake your stuff? Is it on this centralized exchange or you stake it on a machine also?
Yeah, you're going to stake it because I've not run a node before. For both of them, for both proof of stake and proof of work, you have to run a node. Yeah. But now, the way you are running this node now for proof of stake is less energy efficient in the sense that you are going to stake. There are different. I don't really know the process of running a node, but when you want to run a node, there will be where you can stake. I think there are websites where you can like connect and then run a node. But I've not run a node before because I don't use a I don't have a high-end PC or this when I mean high-end PC, you know this gaming PC now, not like a laptop, gaming PC. That's what people used to run nodes. So I don't know the process, but you would have to stake not on centralized exchanges. So it will be on the Ethereum virtual machine, in this case for Ethereum EVM. If it's on Solana, you have to use you run a Solana validator by running a node and all. So I don't know. Does that answer your question?
Yeah, thank you. And also, can
Yeah.
you share like external resources you can also use that can guide us during our training?
Okay, okay. I will do that. I will do that. In fact, most the curriculum I structured here because I this is my first time like teaching in a boot camp. I just decided to do that. Like I just decided, when I saw it, I said, let me just like give back to at least the tech community. So this is the first time. So I didn't really have like an idea on how I can structure it. And because I didn't have that time you get because of other engagement I have. So I have, sorry. So I had to use this Solidity by example. You can check the website out. Solidity by example. So I had to use it. They have a structure, and then I used it to like come up based on their resources. So basically, everything we'll be doing here is on Solidity by example, but it was not like explained per se. Get so I'll be like explaining them and all. So Solidity by example, if you want to go very deep into blockchain, you can use ciphering of drafts by this what's his name? Is that's the is the godfather of every Web3 developer you can see. Um, what is his name
Rollins.
again? Yeah, Patrick Collins. Yeah, Patrick Collins. Patrick Collins. But his course is like long, it's very long. But if you check it, sure. So that's a good resource too if you want to like learn more and more. But yeah, I think from the resource, your capstone project, we're going to build a Uniswap clone. So a Uniswap is a decentralized exchange. So we'll be building a Uniswap clone. So that's like the big project we'll be working on. So yeah, is
Are we going
there
to do
any?
anything that has to do with bots?
What did you say?
About
Sorry, I
before?
didn't get.
The bot you spoke about. I said, are we
Yeah,
going to do
which
any
bot?
project that has to do with bots?
Okay, creating bots. You mean creating trading
Yeah,
bots?
yeah, yeah. Creating bots, yeah.
Well, no, no, actually, that's outside. Creating bots is another different thing entirely, sure. Because you can decide to create a bot that is based on decentralized exchanges. You would interact with smart contract function or
Yeah, that was
DEXs.
like a liquidity bot. And yes, that I was
Yeah.
referring to, like liquidity bot.
Oh, oh, no, no, no. This course is just this curriculum is about smart contracts and not like building smart contracts. But if you want to like create a, though I have a repo where I built a triangular arbitrage bot. Um, I built it with Python and I built it on top of Uniswap. So probably later I can send link to the repo, but you might most likely not understand how it works. So I don't know. But if you
I
want
also want
to,
to ask this question.
yeah,
Okay, which bot do you actually use Solidity to build? Yeah, I know that there are different kind of bots. Which one of them do you actually use Solidity to actually build?
we're not using Solidity to build bots. We are building application, decentralized application, dApps. You get so, and there are different kind of dApps you can build with Solidity. There are different things you can build an NFT marketplace. You can build a decentralized exchange. You can build a DAO, decentralized autonomous organization. You can build a voting smart contract, voting platform. You can build a fundraising platform, that's escrow. You can build whatever you can think of. You can build an insurance policy smart contract. You can build a yield aggregator. You can build a lending and borrowing platform. You can build like anything. You can build anything with smart contracts. You can build a real estate maybe agreements, smart contracts. You can build anything with smart contracts, basically. Your smart contract is just like the back end powering your decentralized applications. Yeah, but we are not building like that. Even the Uniswap clone that we'll build, we're not going to build the front end. We'll just build the smart contract, interact with it, we'll test it, like we'll write test, do unit testing and all, integration test. We'll test it with this tool called Foundry. Foundry is a smart contract development tool. So we'll test it, but we'll not be building, and then we'll deploy it to testnet. But building, we are not building front end because I don't even know front end. I don't do front end. Not that I don't know. I don't like front end, so I don't do it. So
Okay, okay, I understand now.
yeah. So any other question? Timmy, Udoka.
No, I'm okay for now.
Okay. Okay. How about you, Timmy?
Same here. Yeah, I'm good. Everything's good. Thanks for the
Okay.
lecture.
Yeah, sure, sure. It's fine. So, in the absence of no question, I look forward to seeing more of you guys and yeah, more of you guys because most people didn't make it to the call, so they'll have to watch the recording. So I will love more people here. And then see you guys for the next, it's 8 weeks. So for the next 8 weeks. So yeah, thank you for joining me. So see you on Friday.
Thank you. Thank you very much.
All right, you're welcome.
Thank you. Thank you. Good night.
Yeah, good night.